We're about to dive into something that's changing our world from the ground up. And I mean that literally, from the atom up. We're talking about nanotechnology, the science of building things that are just unbelievably small. We always say that technology is making the world smaller, right? Cars, the internet, they've connected us in ways we couldn't have imagined. But what if I told you there's another world, a hidden world, that's already all around us, and it's so much smaller than you can even fathom?
So here's what we're going to do. First, we're going to try to wrap our heads around just how tiny nano actually is. Then we'll get into the weird physics of this realm where the rules we know kind of go out the window. And finally, we'll look at how this super small science is already having a huge impact on our lives and what's coming next.
Okay, so most of us know what microscopic means, right? You think of cells, bacteria, stuff you'd see under a high school microscope. Well, get ready because we're about to go 1,000 times smaller than that. We're entering the nanoscopic world. The key measurement here is the nanometer. What is that? It's 1 billionth of a meter. It is so small that you can't see it with a normal microscope. Nope. You need these incredibly powerful electron microscopes just to get a peek. And that is the playground for nanotechnology.
But 1 billionth of a meter. It's almost impossible to picture. So to really get a feel for this, we need some comparisons. And trust me, this is where things get a little mind-bending.
All right, let's start with something you probably have on your desk, the tip of a ballpoint pen. That's about 1,000,000 nanometers wide. How about a sheet of paper? We're looking at around 75,000 nanometers thick. And a single human hair? That's about 50,000 nanometers. So you see the problem, right? We're still talking about tens of thousands of nanometers. We're not even close to one. We need a better way to picture this.
Okay, new plan. Instead of shrinking down, let's blow something up. Let's imagine we could take just 1 nanometer and make it as big as a soccer ball. Now look at this. This is where it gets crazy. If that 1 nanometer is a soccer ball, then a virus, a tiny little virus, would be the size of a person. A sugar cube would be as big as New Zealand. And a chicken would be the size of planet Earth. I'm not kidding. That's the scale we're talking about. It's just wild.
So, okay, it's small. Big deal, right? Well, it is a big deal. Because when you get down to this nanoscale, you're not just in a smaller world. You're in a world with a totally different rule book. This is all about something called quantum effects. Basically, when things get this small, their properties can completely change. Think about gold. We know it's yellow, right? Well, at the nanoscale, gold can be red. It can be purple. It all depends on the size of the particles. The normal physics we see every day just stops working, and the weird rules of quantum mechanics take over. And that right there is the magic key. Because now, scientists can actually tune materials. They can go in and arrange individual atoms, kind of like playing with the world's smallest Legos. And by arranging those atomic Lego blocks in new patterns, they can give materials brand new abilities, properties they never had before. And look, this isn't science fiction. This isn't some far-off future stuff. It's already here. Nanotechnology is in the products you use every single day. I'm talking about the coating on your eyeglasses that keeps them from scratching, the engine in your car getting stronger and lighter, your phone's battery, and of course, the computer chips that make everything faster. It's everywhere. Let's dive into a couple of really cool examples. Okay, let's talk about batteries, for electric cars. A big challenge is that they often use materials like cobalt, which comes with all sorts of environmental and ethical problems. Well, companies like Tesla are using nanotechnology to design new batteries that don't need it. This is a game changer because for the future of electric vehicles to work, we absolutely need better, more sustainable batteries. Or how about that phone in your pocket or the computer you're watching this on? Ever wonder why they get so much faster every year? Yep, nanotechnology. The little tiny switches inside, called transistors, are the brains of the operation, and we've shrunk them down to the nanoscale. That means we can cram billions, literally billions, onto a single chip. And that's where all that incredible speed comes from. But for me, the most mind-blowing stuff is happening in medicine. Picture this. You have a kidney problem, and you take a smart pill. Now, instead of that medicine just flooding your whole system, causing all sorts of side effects, this little pill travels straight to your kidney. It bypasses everything else and delivers the medicine exactly where it needs to go.
Can you imagine what this means for something like cancer treatment? We could design drugs that only attack cancer cells and leave the healthy cells completely alone. It's revolutionary. So that's what's happening right now. But what about the future? What's next on the nanotech frontier? Well, people are working on some truly incredible stuff. We're talking about tiny little robots, nanobots that could swim through your bloodstream to hunt down diseases. We're talking about materials that could help your body regrow skin after a bad burn, or even repair broken bones. And maybe the biggest one of all, creating super advanced filters that can pull poisons like arsenic right out of drinking water. I mean, a technology like that could literally change the world. Now, we've got to be realistic. This tech is still pretty young. We don't know if these things are right around the corner or decades away. But the path we're on is clear. By learning how to build things atom by atom, we're giving ourselves the tools to tackle some of the biggest challenges humanity has ever faced. So, I'll leave you with this question. As we get better and better at building our world from the smallest possible pieces, a power that's almost hard to comprehend, what's the one global problem you hope we use nanotechnology to solve first?